Hello student, this is Professor Lee. So we're going to start our new lesson. This is going to be lesson number 3, and we are going to talk about organizing data, right? So organizing data. So in this lesson, we are trying to organize data, especially the numeric type of data. So what we are going to do in this lesson, we are going to try to construct, interpret, and frequency and relative frequency table for numerical data. And we're going to talk about histogram and relative frequency histogram for numerical data. And we're going to also talk about stem and leaf display. So if you remember our last lesson, we talked about not numerical value, but qualitative value, right? Something like a name, something like preference in movie, preference in music, your different major, that type of variable. That's called qualitative variable. Now, this lesson, we're going to talk about what's called numerical variable, which is quantitative variable. So it consists it's basically a number form of data, right? Number form of data, right? So first thing that we're going to talk about is what's called the frequency table. That's pretty much the same idea as our last lesson. Last time we had different types of, let's say, preference in movie or preference in music. But in this chapter, since this is going to be a number form, we have to have a slightly different approach. As you can see here, we are going to build or construct a frequency table first, and that frequency table partitions data into classes, meaning we're going to separate the data into several classes or interval. You can think of it as an interval, and show how many data values actually fall into each interval or each classes. And classes on interval are constructed so that each data falls into exactly one classes. So each data cannot be fall into two separate classes. Now, if you check out this example, that probably will clear a lot of questions. Let's say we have this data. So how many data points do we have here? Let's say these data are exam score. So we have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5, 6, 7. So we have 5 by 7. 5 times 7, we have 35 data altogether. Let's say this is like exam score of some class. So what we are going to do, we try to figure out best way to actually summarize this data. I mean, let's say you are a professor, you're teaching this course, and you have 35 students in your class, and you took the first exam, and this is the result, and you try to summarize this into more better way. You can actually summarize it so they can figure out what's going on in a more easier way, more efficient way. You can just look at this whole data as just one, and you can certainly do that, but there's a couple of students who got 100%, and you can see that this student right here got 38. No idea what's going on in their class. And there's a couple of students got really nice score like 100 or 98 or even 95, but you can't really see that clearly the general trend and everything else. So what you are trying to do, you're trying to put it into several different classes. Remember that if you go back, it says that it partition data into classes. So how many different class or category or the interval, whatever you want to call it, that you are going to use? Well, and who's going to decide it? Well, if you are professor and if you are a project manager, if you are who's in charge of organizing this data, it's actually your decision that how many data, how many partition, how many classes that you are going to use. Let's say, you know, you have anywhere between 30 to 100. So let's say every number in 30 something, every number in 40 something, and every number in you know 50 something, 60 something, 70 something, 80 something, 90 something. You know, you make that as one classes, then it's going to be like this. Let's say if you see this table, see this class here, so you divide the class between 30 to 39 and 40 to 49 and 50 to 59 and 60 to, and so forth, and all the way up to 100 to 109. And you can see that each class actually covers same number of different data. How many different number do you have between 30 and 39? Right, try to answer that question. How many different number do you have between 30 to 39? Well, I'm waiting. All right, 10 different number, right? You can count it: 30, 31, 32, 33, 34, 35, 36, 7, 38, 39. So you have 10 different numbers that you are covering in each class. And you can see that same throughout the whole classes. So each class covers exactly 10 different numbers. Any number in the 30s, 40s, 50s, 60s, 70s, 80s, 90s, and hundreds, right? All right. So, you decide to have, let's say 1, 2, 3, 4, 5, 6, 7, 8 different classes. Then you set it up like that. Okay. So once you do that, well, then why did you start with 30s, not 20s? And why did you stop at hundreds, not 120s? Well, look at this data. What's the smallest? Smallest is 38. What's the biggest? Biggest is largest is 100. So you want the class that covers some number in 30s and some number in hundreds, right? That's why you set your class in this manner, right? All right, once you set your class like that, then you are counting, telling, right? You're telling each data point. So what you do, you start from this first one. So you have 68 right there. Then you go to 68, which fall into this class, and you make this one bar right there for that number 68, and you move on to the next number. Now you have 80, so you go back to this table and you have this 80 to 89, this class, then you make one bar right there. Just keep counting, and you go 38, so you go to this table, and you go 38 should be fall into this class, so you make this one bar, right? In fact, this one bar is actually referring to that 38, right? Okay, and you go 83, go to this table, 83 should be here. So you remember you had one bar previously, so you have this another bar right there. Then 73 should be in here, so you go one bar right there, and you move on to the second line, and so forth, right? You get the idea. So that's how you do this telling columns, right, from the data point. Well, frequency column is basically you are counting this tally. So you have this one bar right there, so you have frequency 1. You have no bar between these two, so you have 0, 0. And this class right here, between 60 to 69, you have 1, 2, 3, 4, 5, and 1. That's how they tally. They group them into these 5 bundles, if you want to say. So 1, 2, 3, 4, and 5, and 1 more, and you have 6. So, and you keep counting it, and that's how you set up this frequency column right there. Now, if you add all the frequency, what do you suppose to get? Well, you're supposed to get exact same number as the data points, which is 35. Remember, we had 35 data points. So we have 35 data points, and the total of the frequency is actually 35. All right. So that's how you set up the class, the tally, and the frequency column. Now, once you've set up the frequency column, now you want to set up the relative frequency column. Relative frequency column is actually trying to see how many percent what this frequency means out of 35. What does that mean to have 1 out of 35? Well, how do you do that? Well, 1 divided by 35, then you get this value. 0, 0 is easy. You get 6 out of 35, then you do this, 6 divided by 35, then you get this proportion or the percent, like 17.1%. Let's say you have this, you have 10 out of 35, that's about 28.6% right there, right? So that's how you set up the relative frequency table, right? So you start from the original data point, you figure out how many different classes that you are going to have by checking what's the smallest value, what's the largest value, and each value, each data must fall into one class. So you decide to have class number, the first class is from 30 to 39, the next is 40 to 40. Even though we don't have any frequency here, it's you have to have all these classes all the way up to 100 to 109. Then you count them, get this tally column, and you just count this tally to get the frequency, and then you divide that whatever the frequency by the total 35 to get this relative frequency. So you get this column. So rather than just looking at this whole 35 different number, once you set up the table like that, then you know right away, oh, a lot of students got 80s or 90s, actually 10 each. So that's a 28%, that's 28%, then you roughly get a lot more than half. This is actually 57%, roughly speaking, that you got anywhere between 80 to 90, which is pretty good, right? Which is pretty good. So, and you know that there's like one student who's really struggling, and only 6 of them between 60 to 69, and that's about 70%, and little less than that's got 70s, 14%, something like that. So it actually nicely summarizes this data into something like this table, right? Okay, so like I said again, if you have any question about all this PowerPoint, please email me and let me know. If you want to set up um, appointment, come to my class. I mean, come to my office and try to ask any question. That's also totally possible. So let me know if you have any question. Right, you can email me. So once you set up this table is actually, if you set up to frequency, that if you have this first three column, that's a frequency table, right? Just like that, the frequency table. If you set up to relative frequency, all four columns like that, that's relative frequency table. No big deal. Okay. Now, once you set up the frequency and relative frequency, now we are going to actually make a graph called histogram, right? So frequency histogram or the relative frequency histogram, it's an effective visual display or of organized data organized into frequency table. So once you set up the table is good, but you want even more simpler, more effective, like a picture, a graph, right? That's a histogram. Histogram is pretty easy. I'm sure you can follow this. So for the histogram, the height of the bar is the class frequency, right? Height of the bar is the class frequency. If it's a relative frequency histogram, the height of bar is going to be relative frequency of the class. Now let's check out this graph. So we're trying to set up a graph from this table. Remember, this table is actually from this data. Now from this table, now we try to get this histogram. Notice that each interval between 30 and 40 and 40 and 50 and 50 and 60, each interval became each individual bar, right? Each individual bar. And between 30 and 39, you have frequency of 1. That's why you have this bar, the height of 1. So see that this usual y-axis is frequency. The usual x-axis is actually the exam point, right? Okay, and this, for example, between 70 to 79, between 70 to, that must be this bar. This bar goes up to 5, right? So it goes, the height is 5. Remember that between 80 to 90, 90 to 100, that was 10 and 10. That's why you have this 10 and 10 frequency. So basically, you build a graph called histogram like this. I think this is pretty effective, right? I think this is pretty effective. You build it like that, then you see right away the general trend of your students, right? You know that most of them doing fine. There are a couple of students who need to improve a little bit more, and there's one student who really not understanding at all. Well, once you get this, then the next graph is called the relative frequency histogram. Basically, same thing, right? If you check out from the previous, the frequency histogram, this and the relative frequency histogram is almost the same thing, except this y column. What they used to have is just the actual frequency. Now what they have here is the relative frequency. Now, what was the relative frequency? Relative frequency is this. Remember this table? So, between 30 to 39. It was 1, which is about 0.029, right? 0.029, and that goes here. This goes up to 0.029. Remember, say between 80 to 89 was 28, 0.286. So that goes between this, it goes 0.286. It's about this much. So you set up this y-axis, based on this relative frequency result, because you know that the highest goes up to almost 0.3, right? 0.28. That's why your highest go up to 0.3, because it goes almost up to there, right? And you just evenly divide each line, set up this y-axis, and make that graph just like the frequency graph, right? Let's go to the relative frequency histogram, right? All right, so you start from this table, this data, convert that into a table, and then set up the histogram and set up the relative frequency histogram. One of the effective way of organizing numerical data, right? Numerical data. Okay, now let's go to stem and leaf display. Stem and leaf display is also very, very easy and effective tool. So stem and leaf display is a method of exploratory data analysis that is used to rank, order, and arrange data into groups. It's a fancy, they use fancy word, but this is very, very easy and straightforward. Now let's look at this. Let's say this example. This airline passenger carry-on luggage weight is this. So how many data point? So let's say, there's 40 people, there's a 40 passenger returning from vacation to Hawaii were recorded, right? So each individual data referring to the weight of carry-on luggage of those 40 passenger, right? Okay, so for example, this person right here carrying 30 pounds of carry-on luggage. Let's say this person right here carrying 18 pound carry-on luggage. So stem and leaf display try to organize this data into, we could use that frequency table and the relative frequency table and the histogram and the relative frequency histogram. We can do that, but we are trying to do another technique which is called the stem and leaf display. So to make the stem and leaf display, we break the digit of each data into two parts. What does that mean? This, for example, this 30, you break the 3 and 0, because this data into two parts. There's only two digits, so you can only divide this 3 and 0. For example, this 42, you divide 4 and 2, right? So stem break into two parts. The left group of digit is called stem, and the remaining group of the digit is called the leaf. So this 42. The left side, 4 is going to be stem, 2 is going to be the leaf. Say 38. 3 is going to be the stem, 8 is going to be the leaf, right? That's what they say. And we are free to choose the number of digits to be included in the stem. But in our case, we only have 2-digit number, so we really have no other choice. And once you put the stem parts and leaf part, like look at this data. The smallest one is 0. This guy or this girl is carrying no luggage. So numbers ranging from 0 to, what's the heaviest luggage. I guess it's the 45 is the heaviest. Oh, 47 right here. I think this is the heaviest, largest number. So the stem part, the left number, ranging from 0, the ones in the team, to 1, 2, 3, 4, 5, 2, 3, 4, up to 4. Oh, 5. Oh, there's a 50. Oh, right here. This is the largest, 51. So this number is the stem part, and the second number becomes a leaf part. So for example, this number 30 right here, that's this 3 and this first 0 right there. That becomes 30. Now the next number, 27, that becomes 2, the stem part, and the 7, the leaf part. 12, 1 and 2. So 1, stem part, leaf part 2. And you go 42, that's a 42 right there. And you get the idea, right? You go one by one, you covering each data point, and you put the stem and leaf part like that. Well, these leaves are not ordered, right? So once you have that, you can even transfer that to the ordered part. So, you write the small leaf number first, and then gradually gets bigger. So you have 2, another 2 there first, like this, and the next small number 7, and you have 1, 2, 3, 8, and 9, like that. For example, in the 40s, you have 1, 2, 3, 5, 7, right? In that order, 1, 2, 3, 5, 7. In that order, you reorder it. So there you go. This is it. That part right there, that's a stem and leaf display. And as you can see, this is very effective, very easy to do. Not only you can see the general trend, you can see the majority is in the 30 something pound. And there's a next popular one is 20 something pound. So it says right here, 21, 22, 20. Not only you see the general trend, you can even see the actual individual data points. Which makes it very powerful and effective, right? So this is how you do the stem and leaf display, right? Easy, right? So there you go. This is a procedure. You divide the digit into 2 parts. Left is the stem, the remaining is the leaf. Then you can align all the stem into vertical column, just like what we did in here, and then you figure out the leaf part. Right? I mean, it's pretty much easy. Then you label them, you build it like this first, then you reorder it so that you have the final product. Okay? All right. Now let's talk about homework. So this homework is due October 20th. I mean, if this was like big class, and if this was like in class course, then we would have done like a lot of fun activities and group project together. But since we have very small number of students and this turned out to be an online course, then we are just going to do this as a homework, right? So, consider this data point, and what we're going to do, we're going to make a frequency and relative frequency table, just like this table that we checked here, right? Just like this. You're going to build something like that, and then you're going to make the histogram and the relative frequency histogram, just like histogram and relative frequency histogram. And also we're going to do a stem and leaf display, just like what we did in here, right? So how many number do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 number on the top, I guess another 12 number on the bottom, so we have 24 different number. Now, stem and the, let's say, frequency part, right? Let's say the frequency part. Oops. Okay. So, I'm just giving you some guideline. What we need to do is make a frequency and relative frequency table. So what you need to do for Q1 is that you're going to build a table, right? The first column should be the class. The second column should be the tally. And this is going to be the frequency. And this is going to be the relative frequency. Now class, if you look at this data point here, is what's the smallest number? I guess 19 is the smallest number. So some number is in teens. And what's the largest number? I guess 93 is the largest number. So, class should be from, how do you cover 19? 10 to 19, 20 to 29, so forth, right? And once you set it up, you tally them and then get the frequency and the relative frequency, right? You get the idea, right? You know what to do. And then you have to do histogram and relative frequency histogram. So you have to, like, for Q2, you have to do this, right? And this is going to be, this side is going to be the frequency, and you're going to have this interval for all this different class, and you're going to build a bar graph. And the second graph, you pretty much the same graph. This is going to be class, and this is going to be the relative frequency right there, right? The percent. And then Q3 is the stem and leaf display. So, Q3, you just you have this stem part and the leaf part. So I guess the smallest number was 19, so you have 1, 2, 3, 4, all the way up to, what was the large number? 90 something. And you find this leaf. First you just list all the numbers, and then you reorder it. You reorder this part from small to large, and that's done, right? That's the stem and leaf display. So this is due October 20th. Once you do it, you can take a picture. So you can just do it in the pens and paper. You can take a picture and put the picture file in the Dropbox, or you can scan your pencil and paper homework. You can scan it and you can put it in the Dropbox. If that doesn't work, you can also email me if that works better or easier. But I really prefer you to put it in the Dropbox section in our class E360 class web. Okay. All right. Like I said, if you have any question, don't hesitate to contact me. Right? You can email me anytime. Okay. All right. Take care. Bye bye.